Hey everyone, my name is Grace Goheen, and I'm a product manager here at DBT Labs. Thank you. Previously, I worked as a data consultant on our professional services team, so I might recognize some of y'all from consulting engagements, but I've gotten my hands dirty in quite a lot of different DBT projects. So today, we are going to start by taking a trip down memory lane. So there I was, entrusted with making changes to my team's DBT project for the very first time. I was eager, excited to make a difference, and get my name on the contributors board of our Git repository. I was also blissfully unaware of the downstream dependencies on the code I was changing, and ended up breaking our team's production jobs. I was only concerned with the data assets that I was working on, and never considered how my changes might affect the rest of our DBT project. The more people on data teams I talked to, the more I learned that this experience is all too common. Perhaps you too have accidentally introduced breaking changes to your team's production environment. Or perhaps you identify more with our angry ghost who had to deal with the aftermath of my mistake. But regardless of which ghoul you empathize with, anyone who's been a part of a data team understands how challenging it can be to trust yourself and others when modifying your DBT code. Now, we might devise the simplest solution here and say, how about all of our DBT developers just run the entire DBT project in development before merging their changes into production? And in theory, this should work. By running a DBT build in my own development environment, I'm running and testing all of the data assets that are in my DBT project with any of the changes that I've made to the code. So if this full build passes, I can be confident that merging my changes into the main branch won't break our production pipelines. Fortunately, there are a handful of problems with this approach. Number one, I have a terrible memory. It can be challenging to enforce a manual check. How many times have you asked someone on your team to do something and they just forgot? It's not a process that I'd want to rely on. Number two, I'm a liar. No, really, you have no proof that the DBT build I ran was actually successful. You just have to take my word for it. And because this check was run in my own personal development environment, you have no way to track that each developer's changes are passing this check. Number three, I'm inconsistent. How do you know that I actually ran the correct DBT command to confirm that my changes work? You told me to run a DBT build, but what if I just did a DBT run? Or a DBT build, but just on a subset of my project? Even more, how do I even validate that the code I'm running is the correct command to run? Without an enforced standard, you have no way to ensure that each developer's changes are passing an appropriate validation check. Number four, I'm impatient. Running your entire DBT project every time you want to validate your code changes takes time and money, and this only gets worse as your DBT project grows. I ran a DBT build on our own internal analytics project to get a screenshot for these slides, and I ended up having to cancel it after about 15 minutes because it had only made its way through a portion of our DBT project. So this process may make you start to question if ensuring code quality is really worth introducing developer inefficiency and increasing your warehouse bill. If only there was a way to ensure that you'd still catch breaking changes before they were merged into production, while also avoiding all of these issues. What if I could set up an automatic check that kicked off every time a developer on my team opened up a pull request? What if I could return the status of that check back to the pull request for my reviewers and team to see? What if I could standardize this check so that every pull request was validated in the exact same way? And what if I could speed up this process by only running this check on the data assets that were relevant to my code changes? Well, this may sound like magic, but you can actually achieve all of this with a DBT Cloud continuous integration job. Today, we are going to talk about how a dbt Cloud continuous integration job can help improve the quality, confidence, trust of your data team. First, I'll define continuous integration, or CI for short, what it is and what makes dbt Cloud CI so magical. Second, I'll walk you through the product improvements that we've made to dbt Cloud CI this year to improve the setup experience and scalability of this offering. Third, we'll dive into a demo so that you can walk away ready to set up a CI check in your own dbt Cloud project. And finally, I'll highlight some additional tips and tricks to help you customize your CI check to best suit your data team's needs. Now, if any of you are sitting there asking yourself, wait, but what is CI? Don't worry, you're probably not alone. While CI has been a software engineering best practice for quite some time, it's relatively new to the world of analytics engineering. CI, in long form, continuous integration, is where you set up automated runs and tests of your code base before you merge your changes into production. CI is relevant for anyone who's working in a version-controlled code base, and it is the #1 best way to reduce the risk of introducing breaking changes into your production environment. If we imagine that we have a single main branch for all of our production code, well, when I want to make a change to that code, I should never just make the change directly on the main branch. The first step of every developer's workflow should be to create a new branch to make your changes on. If I'm working on a team that's all working on the same code base, this keeps my work in progress separate from my coworkers. OK, so I've made all my changes on a feature branch. I'm ready to merge that branch back into the main branch. I'll go ahead and open up a pull request, or PR for short, and ask some of my team members to review my code. This is where CI comes in. A set of automated runs and checks are run against my code changes to ensure that they won't break anything when merged into the main branch. So that's how CI works for all code developers. Our software engineers at dbt Labs use CI whenever we add a new feature to our product, make a change to our documentation site, or fix a bug in one of our dbt packages. But how does CI work when the code I'm editing powers data assets? How does CI work for dbt? Well, there are 4 main ingredients of dbt Cloud continuous integration jobs that help ensure my wish list from earlier is fulfilled. dbt Cloud CI is automatic. dbt Cloud integrates with your Git provider, enabling you to trigger a CI check every time a developer on your team opens up a pull request. dbt Cloud CI is safe. Once the CI check has complete, dbt will return the status of that check back to your Git provider. And if you follow our best practices, you'll add a branch protection rule to only allow PRs with a successful status to be able to be merged. dbt Cloud CI is temporary. You don't have to worry about adding clutter to your warehouse. The CI check will build all of your data assets into a temporary schema that's unique to each PR. Now, you can inspect those data assets while you're reviewing the code, but once the PR has been complete, dbt Cloud will drop the schema. dbt Cloud CI is slim. Instead of running your entire dbt project every time you want to validate your code changes, the CI check will only run and test the data assets that were modified and their downstream dependencies. So this keeps your check fast and helps you reduce your warehouse spend. But how does that slim part actually work? Well, slim CI is possible because of 2 things, called deferral and state. Now, these terms can be a bit tricky to understand, so we're going to take a look at a concrete example. So if we all imagine for a moment that I am an analytics engineer at a magic shop, I've got the following dbt project. Well, I want to make a change to my dim wizards model. Maybe I want to remove one of my columns. So I create a new feature branch, I make the change, I open up a pull request. Well, for my CI check to be slim, it should only run and test the models that are relevant to this code change. To achieve this, I'm going to need to use deferral and state. Deferral ensures that I don't have to rebuild my upstream models. So if we remember that dim wizards depends on stage wizards and stage worlds, I don't want to rebuild either of those models. I didn't make any changes to them. So instead, I can substitute in my production version of these models to reference instead. That's deferral. So my ref macro, which identifies the dependencies between models in my DBT project, will compile to my production version of stage wizards and stage worlds, meaning I don't have to waste warehouse spend rebuilding models that haven't even changed. In order to know what has changed, I need to tell DBT what to compare my code to, and that's state. So if y'all are familiar with GitHub, you know that when you go to open up a new pull request, you can see which files you've changed. Well, that's really similar to how state works in DBT. In GitHub, you have to indicate which branch you want to compare to. And in DBT Cloud, you indicate which environment you want to compare to. Most often, this is just your production environment because you want to compare your changes against production. So when I combine deferral and state together, I can select only the models I care about for my CI check. So if I've only changed my dim wizards model, and I run dbt build select state modified, the CI check is only going to run on my dim wizards model. Now, more likely, I also want to check that my changes to dim wizards didn't break anything in fact orders, since fact orders depends on dim wizards. And that's why our default CI command is dbt build select state modified plus, to run not just the models that I've modified, but also their downstream dependencies. And DBT Cloud takes care of all the complicated deferral and state pieces behind the scenes. OK, now that we're all familiar with what CI is, and we've zoomed in on what CI looks like for DBT Cloud, let's walk through the product improvements that we've made to DBT Cloud CI this year to improve the setup experience and scalability. OK, I don't know how many of you have previously set up a DBT Cloud CI job, but if you have, it may have felt a bit like a secret spell. You had to remember to check the right boxes, add the right command, and make sure you set up that complicated deferral piece correctly. We've made a handful of key changes, so the setup experience now feels intuitive and clear. Now in DBT Cloud, when you go to create a new job, you'll be prompted to select a job type: deploy job or continuous integration job. And if you choose the latter, we will automatically configure all of the default components of a basic CI check, including that command we discussed earlier to build your modified models and their downstream dependencies. Previously, you could only defer to another DBT Cloud job, but now you can choose to defer your CI check to a DBT Cloud environment, which means for those of you who have multiple production jobs, your CI check can defer to the most recent run of any of the jobs within your production environment. Now, we also recognize that there were a handful of challenges with the scalability of our previous DBT Cloud CI offering. And we fixed these issues too, so you can now be confident in adding a CI check to your DBT Cloud project, no matter how many people are contributing to your code base. We now support concurrent CI checks, so an unlimited number of CI checks can run at once in DBT Cloud. So 10 developers on your team all open PRs at the exact same time, 10 CI checks will run in parallel in DBT Cloud. And remember, each PR gets its own unique schema, so each developer's changes are going to be tested independently. DBT Cloud will now also automatically cancel redundant CI runs. So if you make a new commit while the CI run based on older code is still in progress, it will automatically be canceled and replaced with a new run using the up-to-date code. So this saves developer time and reduces your warehouse spend. Finally, we've added support for draft pull requests, so you can now validate your code changes even before you open your PR up for review. With all of these product improvements, we believe that dbt Cloud CI is the best way to ensure code quality at scale. OK, now that we've gone through all of the context, let's see this in action. So I'm going to walk through setting up a basic CI check, and then we're going to test it out by making a change to one of our models. All right, so here I am in my example dbt project. And if we pop over to Explorer really quickly, take a look at the lineage, you'll see that this is the same dbt project for my magic shop from earlier. Now, I've already set up a production environment to run dbt Cloud jobs against my main branch, but now I want to set up a CI check to validate my PRs before they're merged into the main branch. So we'll pop into my continuous integration environment. And I've gone ahead and created a separate environment for all of my CI checks. This helps keep your checks organized and also allows you to use different warehouse credentials for your CI check if so desired. So within my continuous integration environment, I'm going to create a new job. And I'll be prompted to select a job type. We've got deploy job or continuous integration job. Spoiler alert, we're going to go with continuous integration job. And I'm going to fill out the remaining job details. So we can go ahead and add a job name. I will go with CI check, very classic, and then a job description. We'll go with CI check for PRs opened against my main branch. Now we can see that the rest of the job's configurations are already set up by default. So my job trigger is already set up to be kicked off every time a developer on my team opens up a pull request. My job command is already set to that default command that we discussed earlier to build all of my modified models and their downstream dependencies. And my job's deferral is automatically set to defer to my production environment. Now, I could override any of these settings, but for my basic use case, this is exactly what I want. So really, all I had to do was add a job name, an optional description, and then this job is ready to go. One other thing I want to highlight really quickly here is that you can also trigger your CI checks via an API call. So for those of you who use a Git provider that we don't have a native integration with, you can still get all of the benefits that I talked about earlier. You'll just want to trigger your CI check via an API call. The only caveat being that you will have to handle dropping temporary schemas on your own. All right. So now that we've created our CI check, we're ready to go. Let's go ahead and test it out. So I'll pop over into the IDE, and I'm going to make a change to one of my models. So let's go ahead and create a new branch to make this change on. We'll call it CI demo. And I'm going to go ahead and make a change to that dim wizards model. Let's say I want to remove one of those columns. So I'll navigate over to dim wizards, and let's say I want to remove the phone number column. So I'm going to go ahead and make that change, and I'll commit my changes to my branch. Of course, I'll add a commit message that clearly indicates the change that I've made. I'll also point out really quickly our project lineage again. And for our CI check to be slim, we should only want the dim wizards model and the fact orders model to run, because those are the only two models that were affected by this change. So we'll go ahead and open up a pull request, and I'll keep it rather bare for the sake of the demo. Once I open up the pull request, we can see that I've got an expected dbt Cloud check. And once this switches over to pending, that lets me know that the CI check has kicked off in dbt Cloud. Now, if I want to see the job details page, just click on that details button, and it will navigate me over to dbt Cloud. Now, I'll reload this a couple of times. And the first thing that I want to point out is that the CI check is overriding my default schema to be a temporary schema unique to this specific PR. So this is PR number 10. It tells you how many times I practiced this demo. And that's suffixed at the end with a _10. So all of my dbt models will be built into this temporary schema. and then this entire schema will be dropped once the PR has been completed. All right, we'll take a look at that DBT build step, and we'll see that this ran my dim wizards model and my fact orders model, which is exactly what I expect because those are the only two models affected by this change. Now, there was an error in fact orders. Don't worry, the demo's pre-recorded, it's on purpose. We'll take a look at the details to figure out what's going on. We've got an invalid identifier phone number in the fact orders model. So it looks like my fact orders model was actually also depending on that phone number field. So if I want to remove this field from my DBT project, I'm going to need to remove it from the fact orders model as well. If we pop quickly back over to GitHub, we can see that I've set up my branch protection rules such that I'm actually unable to merge this pull request into my main branch because my DBT Cloud CI check did not complete successfully. So this is why we recommend setting up these branch protection rules to enforce that CI layer of protection. OK, let's see if we can get this CI check passing successfully. So we'll head back over into the IDE. We will pull up our fact orders model. And I'm going to go ahead and remove the phone number field from this model as well. I'll save my change. I'll commit it to my branch. We'll add another great descriptive commit message to indicate the change that I've made. And once I've committed this change, this is going to kick off another iteration of that CI check in DBT Cloud. So if we head back over to GitHub, we'll see that that DBT Cloud CI check status has swapped back over to pending, which lets me know that there's a new run of this job that has just kicked off in DBT Cloud. Now, this example highlights why it is so important to run not just the models that you've modified, but also their downstream dependencies in your CI check, because you never know how your changes might affect the rest of your DBT project. If I had merged these changes into my main branch after only validating my dim wizards model, I would have ended up breaking fact orders in production. All right, we'll reload it one final time, and we've got a success. If we pop back over one more time into GitHub, we'll see that I'm now able to merge this pull request into the main branch because my code changes have been validated by DBT Cloud CI. All right, now that we've walked through setting up a basic CI check, we're going to end with talking through some additional enhancements that you can use to customize your CI check to best suit your team's needs. So for folks out there who want to prioritize speed over everything else, you could process only a subset of your data in your CI check. Now, this will speed up your check, but it does also add a bit of risk of not catching all breaking changes. So proceed with caution. If you imagine that you have a uniqueness test on the primary key of one of your models, when you run that test in CI on only a subset of your data, it may not catch any duplicates. But once you run that test in production on your full data set, it could throw an error. So this is really for teams who want to speed up their CI check and are comfortable with taking on this risk. For folks who want to go through and resolve not only their errors, but also their warnings as part of their CI check, you could use the warn error flag in your DBT CI check command. This will promote DBT warnings to errors at the time of execution. Now, warnings won't break anything in production. Maybe you have a DBT test with severity set to warn. But this can be a really good process for teams who want to resolve their warnings over time. If any of y'all use the incremental materialization in your DBT project, you should consider cloning your relevant pre-existing incremental models into your PR-specific schema as the first step of your DBT Cloud CI job. This ensures that that second step, the DBT build step, will run in incremental mode, where is incremental is true. This is really beneficial because it will more accurately mimic what will happen when you merge your changes into production, and it will save you time and money by not rebuilding your incremental models, which are often your largest data assets, from scratch for every PR that modifies them. Finally, if you want to enforce alignment with DBT best practices on all future code changes, you could run the DBT project evaluator as part of your CI check. This package identifies and asserts specific recommendations for a given DBT project, ensuring that your project is aligned with DBT best practices around modeling, test and documentation coverage, naming conventions, performance, and more. By running DBT Project Evaluator as part of your CI check, you're enforcing alignment with DBT best practices on all future code changes. OK, we covered a lot today, so let's take a quick look back at what we've learned. CI helps ensure code reliability with automated checks run against your code changes before they're merged into production. We have invested in improving the setup experience and scalability of DBT Cloud CI this year, so you can be confident in adding this check to your DBT Cloud project, regardless of how many people are working on your team. Finally, there are many ways that you can customize your CI check to best suit your team's needs, from speeding up your check to enforcing alignment with DBT best practices on all future code changes. I hope you are all now ready to bring trust and confidence to your data team by implementing a DBT Cloud CI check. Thank you so much. I'm going to be hanging out here on stage along with our designer for the DBT Cloud CI job if you have any questions or want to talk through implementation details of any of those additional customization tips and tricks I talked about at the end. So thank you so much. Enjoy the rest of your conference.